For example 1, we're given the function f of x equals 2x plus 1. And we want to find what is known as the inverse function for this given equation. So maybe just to talk about quickly what that is, I'm going to choose a number for x. I'll choose 3. And I want to plug that into this function. So I put 3 in place of x. I get 2 times 3 plus 1, which is equal to 6 plus 1 is 7. And f of 3 is 7. So for this function, it took the number 3 and it gave us back 7. So maybe like above here, I'll say that's what f does to 3. It goes to 7. What an inverse function will do is just reverse this process. It'll take 7 back to 3. The idea of an inverse is to undo what you just did. And the notation that we're going to use for that is the symbol f for our function, but to the -1 power. That just means the function that reverses what you did. So I'm going to call that f inverse of x. So there should be some formula, there should be some type of equation that when I put 7 into it, it'll give me 3 back, but it also represents the inverse of our given function. There's a very simple procedure to do this. I'm going to rewrite my original function as y is equal to 2x plus 1 instead of f of x equals 2x plus 1. To find the inverse is the function that switches all of your x's with your y's. It reverses them. So I can just go to my equation and I can rewrite it as x is equal to 2y plus 1. And technically, this is my inverse. The inverse is just the equation that switches all of your x's with all of your y's. But it'd be more convenient for us to solve this equation for y, so it's written in a better form for us to work with. And this is going to be very easy to do. I'm just going to subtract 1 from both sides. And then I guess divide both sides by 2. And this is our inverse. In fact, I'm going to rewrite that off to the right here as I just found the formula for my inverse function. It's x minus 1 over 2. So it should be that if I take 7 and I put it into this function, it should give me 3 back. So I'm just going to check to see that this is in fact true. So when I put 7 into my inverse, I get 7 minus 1 over 2, which is 6 over 2, and hey, what do you know? F inverse of 7 is 3. So the original function took 3 to 7, the inverse takes 7 back to 3. So not only does it work for 3, it should work for any number that you choose, 10, 100, 15, -1/2. The inverse function just takes you back to where you started, undoes what you did. And one final thought for this function, f of x equals 2x plus 1, compared to its inverse. If I was to actually write down what this function does to a given number x, it does 2 things. It first multiplies by 2, and the second thing it does is it adds 1. So you can just look at the function and say, if you put something in place of x, by order of operation, it first multiplies by 2, and then the second thing it does is adds 1. Now, if you come down to our inverse function, and you were to list out everything that this does to a number that goes in place of x, well, first it subtracts 1, and then it divides by 2. So I'm just going to write that out as well. So for the inverse, it first subtracts 1, and then it divides by 2. And if you compare the original function to its inverse, they are complete opposites of one another. Like here, step 1, multiply by 2. The last step is divide by 2. Up here, the second step is to add 1, and the first step here is to subtract 1. So like if you know what your function does, the inverse is just going to be the thing that completely reverses it. So like you would start step 2 and you'd say, I'm going to do the opposite, subtract 1. I then go to step 1, I'm going to do the opposite. I want to divide by 2. the formula that does that must be the equation for your inverse. But really the takeaway for this example is if you want to find the inverse of a function, you can label it as such, switch your x's and y's, and then solve this equation like we've done before. The formula that we end up with is the equation of the inverse. And for example 2, I just want to try another example of finding the inverse function. Here I'm given the cube root of x minus 4 plus 1. So you could just list out what this function does in order and then just come up with the equation that completely reverses that. But I'm going to go back to this strategy of I'm going to rewrite the function as y is equal to the cube root of x minus 4 plus 1. And I'm going to switch out every y with an x and every x with a y. And note that the thing that I just wrote is my inverse, the thing that switches all of my x's with all of my y's. The only thing that I'd have to do now is solve this new thing for y to write it as a formula. So to do that, I'm going to subtract 1 from both sides. And I don't have y by itself, but I have a cube root, and that's isolated. So at this point, I could take both sides and raise it to the power of 3. I know that on the left, I'm just going to leave that as x minus 1 cubed. But on the right, I'm left with y minus 4. To get my final answer, I just have to now add 4 to both sides. Now, I could cube this out, but here I have a formula. There are no y's on this side, the y is over here, and this must represent the equation of my inverse. So off to the right here, f inverse of x is equal to x minus 1 cubed plus 4. So I think it's worthwhile looking at this function and just asking if it reverses everything this function does. Okay, the last thing this function does is it adds 1. But the first thing this one does is subtract 1, so that's good. The second to last thing this function does is it takes the cube root. And the second thing that this function does is cube, so they do match up in the middle. This is cube root, but this is cubed. And the first thing that this function does is it subtracts 4, and the last thing this function does is it adds 4. So I'm pretty convinced this must be the formula for the inverse of this equation.